All right, let's talk about absolute value inequalities. Now, I know they can look kind of scary, but they're really just about one simple idea: staying close to home. In the next few minutes, we are going to totally demystify the less than rule and turn this tricky-looking problem into something you can do without even thinking. So let's start with a question to kind of get our brains warmed up. Forget all the formulas for a second and just picture a number line in your head, okay? If you're standing right on zero, which numbers are less than 5 steps away from you? Just take a second and think about it.
So, if you were thinking, oh, that's easy, it's 1, 2, 3, and 4, you're about halfway there. You're on the right track. But remember, absolute value is all about distance, and distance works in both directions, right? That means we also have to include -1, -2, -3, and -4. So really the answer is all the numbers that are kind of trapped or sandwiched between -5 and 5.
And you know what? That idea of being trapped or sandwiched is the absolute secret to solving these things. It leads us straight to this really easy-to-remember rule that's going to make these problems a piece of cake. We're going to call it the less than sandwich.
I love this way of thinking about it. A less than inequality is basically telling the variable to stay close. It puts it on a short leash. It's not about going far away. It's about defining a very specific, controlled little zone where the answer is allowed to be.
So here it is, the little memory trick you're going to want to write down. Less than. See how I'm really hitting that and? There's a reason for that. Less than problems will always turn into and problems. This means our solution has to be bigger than one number and at the same time smaller than another. It's completely trapped.
And this slide just shows you that translation perfectly. You see the original problem on the left? The absolute value of x is less than 4? Well, that becomes the sandwich you see on the right. -4 is less than x, which is less than 4. You just take that number, make a negative and a positive version of it to be your two walls, and you stick the variable right in the middle. It's a direct swap.
Okay, so we've got the rule, we've got the concept. Let's actually put it to work and see how this plays out with a couple of problems. This is where the theory becomes a tool you can actually use to get stuff done.
Here we go, our first one. Nice and easy. The problem is to solve the absolute value of x is less than 7. So, using our new rule, how would you set up that sandwich?
Yep, you got it. It's that simple. You just drop the absolute value bars, take that 7 and use it to build your walls. The solution is just x is stuck between -7 and 7. And for a problem this basic, once you've written down the sandwich, you're literally done.
Okay, let's step it up just a little bit. Here we've got the absolute value of x minus 2 is less than or equal to 5. Now, step 1 is exactly the same. Make the sandwich. Trap that x minus 2 between -5 and 5. But we're not finished, right? Because we need to get x all by itself. So for step 2, we got to isolate x, and we do that by adding 2. But, and this is super important, you have to add 2 to all 3 parts of the inequality to keep it balanced. And that gives us our final answer in step 3, x is trapped between -3 and 7. Now, like any good rule in math, there's always an exception. There's a little curveball that can really get you if you're just going on autopilot. We're going to call this one the impossible trap.
So what about this? Your first instinct might just be to start building a sandwich, right? Put x between 3 and -3. But wait a minute. Before you write down a single thing, let's just think about what this problem is really asking.
This is the key. You have to stop and think, what is absolute value? It's just distance from 0. And think about it. Can you ever have a negative distance? I mean, whether you walk forwards or backwards, the distance you travel is always a positive number, or 0 if you don't move at all.
So can a distance, which is always positive, can it ever be less than a negative number like -3? No way! It's logically impossible. So the answer here is simply no solution. Don't fall for it. Don't even try to build a sandwich. It's a trap.
All right, so we've got the rule, we've got the exception, but I know what you might be thinking. When am I ever going to use this stuff? Well, this whole idea of a trap or a zone is actually super useful in the real world. Let's look at a classic example involving pizza. So just picture this. There's a pizza shop on a long straight road, and it's right at mile marker 20. Now, they have a simple delivery rule. They only deliver to houses that are within 5 miles of the shop. That little phrase, within 5 miles, is our big clue.
So how do we turn that into math? Well, if your house is at some unknown mile marker, let's call it x, then the distance between you and the pizza shop is the absolute value of the difference, right? So the absolute value of x minus 20. And since that distance has to be within 5 miles, it has to be less than 5. And boom, just like that, we get our inequality.
And would you look at that? We can solve this with our sandwich method. We trap x minus 20 between -5 and 5, we add 20 to all three parts to get x by itself, and we get our answer. The pizza delivery zone is anywhere between mile marker 15 and mile marker 25. So if you live at mile marker 14, sorry, no pizza for you tonight.
So the big takeaway here is that this whole sandwich idea isn't just for a math test or for pizza delivery. It's used everywhere to define an acceptable range, what engineers and scientists call a tolerance. Think about the perfect temperature range for a machine to work, or the acceptable weight for a bag of potato chips, so it's not too full or too empty. These are all real-world less-than sandwiches. What other ones can you think of?